Hello everyone. So I've been asked to continue our introductory lectures on analytics, and today we are considering the concept of normalization. Now you could remember that we had introduced you to concept of measurement and measurement scales, their respective classifications and types, and why it is important in analytics, where we mentioned that it enables you to choose the right test statistics for your analysis. But as time goes on, you might want to combine all the measurements you have taken to make a unified decision, or to make a unique prediction about the data you've gathered so far. So before you are able to do that, you are going to conduct what we call normalization. So by way of definition, the normalization is one of the pre-analytic processes that enables you to rescale your data appropriately, such that all the data sets, irrespective of the source of measurements or the measurements unit, you will arrive at a unified scale. It could be dimensionless or it could be scaleless, but it's going to arrive at a uniform scale in your measurement. So the particular one that we are going to consider is called the min-max approach. The min-max approach. Now, as the name implies, you'll be able to identify the minimum value of the data set as well as the maximum value of the data sets. So if you are given any specific data set, say x defined within this range, x1, x2, it could be a finite data set, then you want to normalize any of the data points, say data point p. You are going to pick that data point p and subtract it from the minimum of the data set divided by the maximum of the data set minus the minimum of the data set. So the essence is that this rescaling process will enable all your data to be in the same scale within a defined fuzzy bounded region of 0 and 1. So all the data points will be defined within this range. Now it will help you to visualize the data set effectively, as well as being able to identify possible patterns in the analytics. This will also enable you to reduce the bias in the pre-analytical processes, as well as improving your precision and accuracy in your analysis. So we make use of this when you are going to use a machine learning algorithm, like neural networks, such as maybe deep neural network, could be a CNN, convolution neural networks. So that is when you apply the min-max approach. Although it also helps you to reduce the outliers, it is that sensitive to reducing the outliers. So this is the particular approach that you use when you want to apply those kind of machine learning, maybe the k nearest neighborhood as well, KNN, or cluster analysis or cluster modeling. So this is the approach that you use for machine learning analytics. Then the second one is the second one that we are going to consider is called standardization. So the standardization process is a way of rescaling your data such that you will be able to see how spread the data point is from the mean. So in this case, if you are given a data set, say x1, x2, maybe a finite data set, you are going to standardize a particular data point by subtracting that data point p by the mean value or the average estimation and divided by the standard deviation. Now in this case, the range is not going to be 0 and 1. It could be a positive value, it could be a negative value, and the assumption for standardization is that this data set is going to follow the normal approximation. It follows a normal approximation. That means it has a mean value, it has a mean value of 0 and a standard deviation of 1. Now this particular method is very robust to remove your outliers or to identify the outliers in your analytics, as well as reducing the possible bias that you have in the measurement. So once measurement comes from different scales, for instance, you could decide to measure the age range of the students, you can decide to measure the gender, you can decide to measure the speed of completing a particular task, or you can decide to measure cognitive performance. So all those measurements have different scale. Maybe some could be in centimeters, measurement could be in kilograms, depending on the unit. So once there is variations in the unit of measurement, which is very much practicable, you have to normalize your data set. It's either you use the minimax approach or you use the standardization approach. So these are the two fundamental approaches that you can use to normalize your data. An example of when to use a standardization is that it must be normally distributed. Example is a regression model. When you want to conduct a regression model, you have to standardize your data. Or you want to conduct a data reduction process, that is a principal component analysis, you have to standardize your data. In fact, Z-test, for you to conduct Z-test, you have to standardize your data. Now, this is one of the misconceptions that we are trying to correct for those that want to, or those that have been using the fundamental inferential test statistics, even analysis of covariance and the rest. You have to, first of all, standardize your data effectively, because this will enable you to train the data, and also it will maintain it maintains the integrity of the data sets, and but it will reduce the bias in the process of data analytics. So these are the two simple methods that you can use to conduct your data analytics. So in subsequent lecture, we might consider error estimation and estimation threshold. So in that case, we are trying to say that, okay, irrespective of the measurements you are going to use, or the scales you want to use, or the normalization approach you are using, there is going to be some form of error in the process. So we are going to conduct some form of error analysis to consider, okay, the decision we are going to make is robust based on the analysis that we have gathered so far. So error estimation and error threshold is also a particular concept that is very fundamental in learning analytics, which we are going to consider in our next lectures. But we will take examples in our real class, so please ensure that you follow us in YouTube channel to see the full lectures. Thank you so much.